Hello everyone, welcome to this lecture. In this lecture, I will explain the ACID property in relational database management system. What is ACID? ACID is a set of properties of database transaction, especially in a relational database, that ensure data integrity, consistency, reliability, and every successful transaction in SQL Server has to pass this ACID test to keep database in consistent state. Either any transaction failure, any power off, or any other problem, ACID makes sure that the database must be in a consistent state. ACID stands for Atomicity, consistency, isolation, durability. Let's explain this step by step. Atomicity means a transaction either all steps are completed or none of them happen. If any part of a transaction fails, the whole thing gets rolled back like it never happened. Transaction management system often use login mechanism to enable this rollback feature. In this image, we can see there are 4 write operations. If any operation is failed, the whole operation will be rolled back in previous consistent state, and for that a logging mechanism is used. Let's give an example. Imagine we are building a banking app that transfers $100 from Alice to Bob account. In this case, Alice sent $100 to Bob account. This means there's 2 updates. One update, the Alice account will be withdraw $100, and in Bob account $100 will be credited or add $100. Atomicity ensures that both updates either happen together or not at all. That means in these 2 accounts, these 2 update operations should be happened. No error, no failure. If any operation transaction is failure, like if Bob account is failure, then Alice also roll back. So here is an image clearly explained that if the Bob account, if the credit is failed to add, then it will be a roll back, and also the Alice account, it will update or keep the previous balance. So we don't worry with loss of extra money. Consistency. A transaction must follow all the rules and leave the database in a good state. Any data written during a transaction must be valid according to constraint, triggers, other rules that we actually set up. The database system itself enforces consistency by automatically checking for constraint violation during transaction. Let's give an example. Let's say we have a role. We create a role that user account balances cannot go less than $50. That means we are set a role in Alice account that the balance should not less than 50. Now, if the Alice account have $50 and we want to withdraw $100, the consistency, it will be consistency violation. So the transaction will be cancelled to violate the consistency. So consistency stops invalid data from messing up the database. Isolation. Isolation is all about how concurrent transactions interact with each other. For multiple transactions at the same time, each transaction has the database all to itself. Let's see the image. There are multiple transactions, transaction A and B, and both transactions keep the database, hold the database its own self. This highest level of isolation is called serializable. Serializable transactions run one after another provide in strongest consistency, but serializable slow down the process because each transaction has to wait its turn. Let me if until the transaction A is completed, transaction B should wait to complete transaction A. To speed things up, databases often provide lower isolation level that allow more transactions to run simultaneously. But there's also some problem. The lower level can sometimes lead to inconsistency like dirty read, non-repeatable reads, and phantom read. Now explain this term. Dirty read happens when a transaction sees that data was changed by another transaction that has not been committed yet. Let's give an example. Transaction. Imagine a bank account with $100 and transaction T1 withdraw $20 but does not commit. It just withdraw but still not commit. If transaction T2 read the balance before T1 commit, it will see $80. Let's give an example. Imagine a bank account with $100. Transaction T1 withdraw $20 but doesn't commit. If transaction T2 read the balance before T1 commits, it will see $80. But if T1 roll back, that 80 balance never truly exits. It is a dirty read. So the read committed isolation level prevents dirty reads by making sure a transaction can only see committed data. But it can still have non-repeatable read, where a transaction reads the same data twice and gets different result because another transaction changed the data in between. Let's give an example. So say you check your bank balance the $100. Then another transaction withdraw $20 and commit. So after commit, the balance, if I check, it will again 80. So initially transaction T2 check the balance is 100, but meanwhile time transaction T1 withdraw 20 and commit. So after commit, transaction T2 again read the data and it see that the amount is now decreased and it will be 80. That is non-repeatable. So read committed can also have phantom reads where a transaction reruns a query and gets different result because another transaction added or deleted row that matched the search criteria. Imagine a transaction that lists all bank transfer under $100. Meanwhile, another transaction add $50 transfer and commit. If the first transaction reruns its query, it will see the $50 transfer that was not there before. It is a phantom read. I think we all understand. Initially, the transfer amount is $100, but another transaction added $50 and commit. So when the first transaction rerun its query, it will see that $50 is transferred. That was not before. It was phantom read. The repeatable read isolation level prevent non-repeatable reads by giving each transaction a consistent snapshot of the data. But this still have phantom read issue. So we can say which level is best. It depends on the business requirement. So let's compare these 3 points: serializable, repeatable read, and read committed. Serializable is best for accuracy and consistency. No dirty read, no non-repeatable read, no phantom read, but it is slowest. Repeatable read, good balance of safety and performance. Prevent dirty and non-repeatable reads, but phantom rows still possible because it rerun the query. So read committed, it was fast and widely used. Default in SQL Server, Oracle, and PostgreSQL. Prevent dirty read, but still allow non-repeatable read issue. In conclusion, serializable is the safest but slowest. Read committed is the most practical and commonly used. Repeatable read is in between serializable and read committed. Durability. Durability means once the transaction is committed, it's permanent, even if your database crashes or loses power right after. Durability is usually achieved by writing transaction log, using write-ahead logging to persist changes to disk before confirming the commit. So we can see from this image, in distributed database, durability also means replicating data across multiple nodes. So if one node goes down, you don't lose any committed transaction. They are safely stored on the other nodes. So conclusion, to quickly sum up all these things, we can say Atomicity rolls back all after fail any transaction. Consistency, follow the rules, constraints, etc. Isolation, prevent interfaces, and durability makes sure committed stick. So thanks for watching.